All right, I'm Joshua Faulkner, and it's good to be with you today. I appreciate the invitation. I'm excited to talk about my work over the past several years and what is happening right now in my research and what we expect to be tackling in the next several years. So I think to start things, I want to give a little bit of context for the position I have at University of Vermont in the Center for Sustainable Agriculture. It was a position that was created after tropical storm came up through New England and impacted Vermont agriculture in a significant way, doing $10 million worth of damage and 20,000 acres in just agricultural impacts. And I think kudos goes to University of Vermont for seeing the need to have someone kind of work one-on-one with farmers and have programming in this area of adaptation to climate change. I think we were the first university in the country to do that, to develop such a position and extension program. So that's what I've been doing for the past 7.5 years. And I say that because I first want to begin my presentation by providing some context in terms of how climate change has been impacting farmers, but then also how farmers have been responding in some sense and where the needs are and the intersections between those impacts on agriculture and natural resource concerns. So, and then I will move into talking about just a handful of research projects that are current or upcoming. And I'm not going to delve deeply into any particular research project. I think there are probably a wide array of disciplines represented in the audience here today. And one of our objectives, I think, with the GUND Exchange is to generate conversation. And I want to hear ideas and thoughts and potential synergies and collaborations. And I think the best way to do that is to be broad and to get thoughts and your input from other disciplines. So just kind of to frame the conversation and to give you an idea of my approach for this. Okay, so I'm going to jump right in here and start with that climate change background. And so we know in the Northeast that it's been getting wetter. You know, this is one of our hallmark impacts of climate change. And here's some NOAA data that shows over the past century or so, we've seen an increase in annual average precip of about 4 inches. Not such a big deal. You know, if you're on a farm, this is multiple generations of farmers that and this 4-inch increase is spread over those generations. Certainly something farmers can withstand and adapt to. However, when you look at the climate district specific data in the state of Vermont, you see a very different story, especially when you look at the last 30 years or so. You see increases of 9 inches in the Northeast Kingdom, 7 inches in the Champlain Basin, and 5 inches in southern Vermont. And so this is, you know, in the 30-year time frame, this is one generation, maybe a little bit more, 1.5 generations on the farm that are seeing a much larger increase in that annual precepts. So this is concerning to farmers. This is something they're taking note of. This is something they're trying to adapt to and really has them back on their heels. And this is shown, I think, exhibited in some of the USDA risk management agency data that is put together for all states. And this is the data from 2001 to 2010 for Vermont, and this is based upon where crop insurance payments were made to farmers when crops failed. And you can see that over half of the pie here in the state of Vermont, our crop failures were due to excess moisture, and that's reflected in the conversations I have with farmers as well. And I think what's interesting is that when you move westward out of Vermont or southward into other states, this pie looks very different. The drought slice of this pie starts to grow larger, and there are because of the drought impacts that are occurring in the West and the South out of New England. And then it's not just, of course, that it's getting wetter on an annual basis. It's the change in patterns of precipitation, and this is a figure from the latest National Climate Assessment that shows the percent increase in very heavy precipitation events, and every region is seeing this, but none that to the degree that the Northeast is seeing. We're seeing a 55% increase in these types of events, and to what's I think interesting and telling is that when you have conversations with farmers, and I should say there's a variety of, I think a wide range of beliefs around climate change from farmers, both ends of the spectrum, and that when no matter where a farmer's beliefs lie, whether they're a climate skeptic or not, they will talk about how they've seen this right here occurring on their farm, this increase in extreme events, and how much more difficult it is to manage for these storms and maintain soil and prevent erosion. So that I think it's, regardless of their beliefs, this is fully acknowledged and is impacting our growers. And here's just one example, a very kind of powerful image in my mind of the impact of these storms on farms. This is in Williston, Vermont, and this was in I believe it was 2014, after one single event in mid-July that just kind of came through the Burlington area and resulted in this level of erosion from this cornfield. And this is sweet corn, actually not field corn. And this is, I'm over 6 foot tall, and so this gully is probably 2.5 to 3 feet deep, and just kind of shows you the level of erosion that we can see from these types of events. And there's more erosion that's outside of this frame that I'm not able to show here with this photo that Vern Grubinger took when we were visiting a vegetable farm. But to me, as a soil and water engineer who studied, erosion in school, and I had never seen this degree of erosion in agriculture in modern times, outside of the photos I saw from the 1930s in the Dust Bowl, back before we understood how important soil conservation was in the U.S. And so I have a guilty grin on my face because this was kind of a special moment for me to see this, but it's really tragic for the farm, of course, that this soil is the foundation of their cropping system, and there was quite a bit lost here from this one event. And then I put up a modeling projection from these are some USDA ARS scientists out of the Midwest and Southwest that have done some work looking at erosion and climate change, and they've kind of projected that we'll see this disproportionate increase in erosion due to as annual rainfall increases. And so this should give us concern here in New England and the Northeast, because, if we think back to the data I showed on the increase in precipitation in the Northeast Kingdom, that's almost a 23% increase in annual precip. And if this projection holds true, that would be a 40% increase in erosion. So somewhat staggering. And I realize this projection was developed for, likely different soil types and different cropping systems, but still, even if it's not to this full 1.7 times factor, it's likely still an increase, and we should adjust our conservation practices to account for that. And then it's not just that farmers are losing soil, it's that farmers are losing actual fields, productive areas of the farm, entire, land area. This is a farmer in South Royalton on a branch of the White River after Tropical Storm Irene. And Vern took this photo as well, and you can see just lost an entire chunk of this field. And I think this is especially tragic in a state like Vermont, where outside of the Champlain Valley, we have quite a bit of topography, hilly, wooded soils, and a lot of the productive agriculture really happens on these very fertile floodplain soils. These are soils that are critical for the local food systems that we're so proud of in Vermont, and farmers depend on these soils for specialty crops. And so, but these soils are also those that are most vulnerable to the effects of climate change, and which we know are more extreme events, and the flooding associated with those events. And then kind of to tie climate change together with water quality, and kind of where my work lies is that we know that when we lose these soils from farms, from agricultural lands, that they go somewhere, right? And many of them end up in receiving waters and impacting downstream aquatic communities. This is a NASA photo aerial image of the Connecticut River, and just transporting all this sediment from Tropical Storm Irene, after it ripped up through New England, into the Long Island Sound, and you know, some USGS scientists showing a summary from some of their work that these events are leading to 5 times or multiple times sediment delivery than the typical annual average would be. And so this is very concerning too. And of course, we know that for those who study Lake Champlain, that these sediments from farmlands, and all of these sediments, I should say, are not from agriculture, but certainly much of them are, that these sediments carry phosphorus with them into downstream, into those receiving waters that are susceptible to cyanobacteria blooms. And this is a image of Lake Erie. This is a NOAA project, photos from 2017 of a cyanobacteria bloom just moving toward the shoreline in the western Lake Erie, and just such a surreal photo. But this is driven by those phosphorus molecules that are bound tightly onto sediment particles, and there's dissolved phosphorus too. But we know that, you know, the more sediment is transported, the more phosphorus is transported, and it helps to fuel these events like this. And then the other factor, which I think is going to help link us into some of the research I'm going to discuss, is that how farmers are adapting to these increased extreme events and this increased annual precipitation events. And one of those key adaptations is the installation of tile drainage on agricultural lands. And for those who aren't familiar with tile drainage, I talk to a lot of audiences, and often I assume we all know what this is, and of course we don't. It's not actual tile. It's plastic corrugated pipe that is literally placed underground beneath the root zone of a crop, with the idea of draining water from the soil profile so that there's no adverse impact on the growing crop due to excessive high water tables, excessive precipitation. And, you know, in my observation, I think anecdotally, this is the #1 adaptation that farmers are using to adapt to climate change. And this is not just in row crop systems and in dairy agriculture. This is in fruit agriculture. This is in vegetable agriculture, and this is kind of widespread. And so it is clearly beneficial to the farm. But there are some very concerning reports from the Midwest. Kevin King, the USDA research group, who leads a research group out of Ohio, had kind of put forth some of the first data, most influential data on this 5 years or so ago, looking at phosphorus loads coming from tile drains in soils that are somewhat similar to those of the Champlain Valley. Clay soils in the western Lake Erie Basin. And so there's been some grab sampling here in the state of Vermont, and agencies have been responding, the Agency of Agriculture, with updated rules on the required agricultural practices, and issuing reports and lots of discussion in the legislature about tile drainage and the concern that we have that it's adversely impacting our water bodies. And I want to, you know, make the point here that I think this is really driving a lot of the research, and the importance of having local data collection, local research efforts. Of course, the data that came out of the Midwest is important, but we do have different soils, we do have a different climate, we do have different farming systems, and it's important that we collect our own data on these tile losses in the state of Vermont. And I think this is especially important as we think how do we move forward with adoption of conservation practice? What are the right management approaches to addressing these losses? In order to do that, we need to have that locally based research, and that kind of opens the door for some of the work that we've been doing the past couple of years and will continue to do. And so my last kind of framing slide before I jump into my research is, kind of this idea that the intersection of this farmers needing to adapt to climate change, to build resilience in their agricultural systems, has a strong overlap with water quality and kind of the impact that climate change is driving agriculture to have on our natural resources. And so at that intersection exists this soil and water management field, and that's kind of where my work focuses. And then there's this kind of overlap between water quality and climate change mitigation opportunities, which I'm not going to get into. I work with some other folks at UVM and Carol Adair and others on kind of the greenhouse gas issues in agriculture, but this overlap between water quality and mitigation opportunities, I think, is where the work in nutrient management becomes really important. And there's lots of opportunities there as we can change the way we manage our nitrogen to reduce nitrous oxide emissions, for example. And so there's I think all of these factors are very closely connected, and there's just lots of opportunity for very rich research to occur at these intersections. Okay, so to jump into my research and kind of to broadly kind of put my research into the research we do in my program into various buckets, the biggest thing we do is monitoring, field-based monitoring and practice, BMP, best management practice evaluation, or conservation practice evaluation. And this is done at multiple scales, from the plot scale to the field scale to the watershed scale. And I'm going to talk specifically about two projects today. One will be at the field scale and one will be at the watershed scale. And then, having an extension appointment, one of the objectives of my work is to connect these field-based data to models that inform policy and inform programmatic decisions by our state and federal agencies like the NRCS. And so we're done some modeling and continue to do modeling work to build scenarios of how changes in programs and implementation of conservation practices may affect water quality outcomes. And then ultimately, we also want to use these monitoring data and modeling tools to inform applied tools, management tools that are used by farmers and agricultural service providers on the ground, out in the field. And so that is, in a very real sense, that connection this monitoring data ultimately makes on the farmers and our agricultural community and how they practice soil and water management and nutrient management. So in order to kind of frame how most of my field monitoring research happens, I want to first talk about the typical experimental design, and that's the paired watershed approach. And so this is done with a study, typically a study watershed and a control watershed setup in the first year of the work, and those being intensively instrumented with both flow monitoring and automatic sampling equipment, so that we're capturing the hydrology of the watershed, but we're also capturing nutrient exports and nutrient concentrations in those watersheds. And then we go through at least a 1 to 2 year calibration period with those stations in place, that instrumentation in place, with the objective of establishing kind of the inherent differences between the hydrology of the study watershed and the treatment watershed. Before we do any implementation of a best management practice to evaluate the effectiveness of that best management practice. So then, once we've established a nice strong relationship, 1 to 2 years between those watersheds, we then move into a treatment period, and that's where we actually apply that BMP to the treatment watershed, and we can correct the results for those inherent differences in hydrology in that treatment period because we had that calibration period, and that's really, really important. And then the treatment period lasts for 3 years or more. And so this is long-term work. Our monitoring methods are that we use a variety of different tools for this. I'm showing a surface flume on the right there. This is for capturing surface runoff. There's an end of pipe weir there at the top center. You can kind of see water rushing through that on the top left. And then there's a mag meter on the bottom left that is installed on a pipe after a manhole's been dug, excavated over top of a tile line, and outfitted with this device. And so the important point here is that it's we measure, for these studies, we have to measure the flow of the water, the mass of the pollutant in the water, in order to generate a total load. The concentrations are not sufficient. The concentrations are in some ways not very helpful unless we have this total load of that constituent leaving the field. And so we work very hard to measure the hydrology to capture the flows from wherever, whether it's surface or the subsurface. And so jumping into a couple of studies I want to talk about. The first one is at the Watershed Scale, and this is what the acronym is CEAP, C-E-A-P, and that stands for Conservation Effects Assessment Program. And this is a nationwide network of CEAP watersheds that have been established, and Vermont just received funding to develop a CEAP watershed in September of 2019, the first investment in I think a northeastern CEAP in maybe 10 years or so. And we're currently now in the calibration period, and this is at least a 10-year study. And the objective with this is to evaluate at the watershed scale the effect of the investments in conservation practices that our state and federal agencies are making in agriculture, and not just evaluate them in terms of at that field scale, but also aggregated. What is the overall impact at a much larger scale? We're cooperating with USGS on these. They're doing our stream gauging for us, and for anyone who's curious, I can give you a link and you can see the 3 different monitoring stations we have established, the 3 different stream gauging stations we have established, and actually see when our sampling units take water samples during storm events. And we're evaluating those, we're analyzing those samples for total phosphorus, total dissolved phosphorus, suspended sediments, and a few different nitrogen analytes. And almost, I would say, as important as the water quality data collection is also the documentation of land use and conservation practices on all of the farms within that watershed where we're monitoring, and this has to be done on an annual basis. So you can imagine watersheds here in the next couple of slides. And so it's a tremendous amount of legwork, and the need to establish strong relationships with farmers before going into a project like this is paramount. That we need farmers' trust to talk about what they're doing on every single field within the watershed. And so this is a lot of work in and of itself, in addition to the water quality data collection. And then we're also doing some soil health testing across these watersheds. We have funding to do, starting next week, to do soil health tests, over 70 soil health tests on fields within these watersheds, and then continue to monitor soil health for a number of years to see if the soil health signal correlates with the water quality signal. And if that's one thing that is not, I think the literature is very weak on, is this correlation between soil health and water quality at a watershed or a field scale. So here's our first watershed. This is our treatment watershed. This is the Dead Creek watershed, which those of you who are familiar with Addison County, it stretches the west branch and the east branch of the Dead Creek, stretch from Addison down through Bridport down into Shoreham. This is about a 15,200 acre watershed, so you can imagine how many farms and fields are within this watershed, and these are all heavy clay soils, and this is about 75% agricultural land use, and the soils are very representative of the Champlain Valley, these Virgins and Covington and Kingsbury clay soils, which are farmed, but are up to 70-75% clay fraction in some cases. And then our control watershed is just to the northeast of the Dead Creek, and that's what's called the headwaters of the Little Otter, which is just a sub-watershed of the Little Otter Creek. This is about 22,000 acres, stretches into Moncton, Bristol, and New Haven. Again, heavy clay soils, and this is about 50% agriculture. And so this will be the watershed that we will not accelerate conservation practice on over the next 10 years or so. This one will just move forward, business as usual. It won't have any additional attention paid to it. And so just to present a little bit of just new data, like I said, I kind of want to focus on some of the newer and upcoming projects we have. So some recent data we have from March through August, base flow samples collected on those three watersheds. The Dead Creek, west branch of the Dead Creek, we'll just focus on total phosphorus concentrations, has over 500 parts per billion in phosphorus, and then the east branch of the Dead and headwaters of the Little Otter, just over 100 parts per billion. And to kind of frame this, the Otter Creek Lake segment target total phosphorus concentration is around 14 parts per billion, and that's I believe set forth in the TMDL documentation. So clearly we have a lot of work to do here. It's in one way it's kind of frustrating to see levels this high, but in the other way, it shows that there's a lot of opportunity for us to show an effect through this watershed scale monitoring work. And then the next study I want to highlight is a field scale study funded by the Lake Champlain Sea Grant, and this also occurs in Addison County in the town of Panton. And in this particular study, this is the first study of its kind in Vermont, where we're monitoring both subsurface flows and surface flows, which is really difficult to find a field that lends itself to that type of monitoring approach. And this is again 77% Covington clay soils, these heavy clay soils. This is a corn silage field, and we have fantastic farmer cooperation at this site. And so here's just a schematic of the tile networks and the surface watersheds which are being monitored at that particular field. And this isn't the actual field itself, the image I'm showing. I wouldn't want to pinpoint that any particular farmer's field, but just kind of shows you the relative size of the tile networks that we're monitoring, and then these sub watersheds within those tile networks. And so that's how this study has been moving forward for a little over a year now. We have some preliminary results that I want to present here. And this is from last fall into late winter, at which point monitoring, because of the pandemic and then the drought which followed the pandemic, we had very little runoff or tile flow. But this is just representative of 13 distinct runoff events at these fields at this study site. And to kind of put these into context before we get into the table, it's generally kind of batted around in the agriculture conservation circles that roughly we should not be seeing any more than 1 pound per acre per year of total phosphorus from ag land. And that may be somewhat of a sustainable level for the lake. And so you can kind of use that as to compare the total phosphorus loading we're seeing from these fields over from October into the 1st of February. And I'm showing surface export, subsurface, export in base flow, and then subsurface export in storm flow, and then a combination of those subsurface exports, base plus event, and then a total phosphorus export from those fields, surface and subsurface. And so what, I think the big takeaways from this data for me are that we're seeing about 35 to 60% of the subsurface total phosphorus flows coming from storm flow events. It's not in that slow drain, that base flow that occurs, in between storm events, that it really happens at the time of the storm event or directly following the storm event. We see hydrograph peaks in lots of export. And then about 68 to 82% of the total loss from this particular field is from the subsurface, which is really concerning. In the Midwestern studies, they've shown about 40%. And here we're seeing, at least at this field, 68 to 82% of the total loss. And then the total surface and subsurface is for this, October to February time period is 1 over 1 up to 1.34 pounds per acre. So certainly we're higher than that kind of rule of thumb, 1 pound per acre per year that is generally accepted as possibly a sustainable level of P export from ag lands. And then I want to show another study quickly from this is work I did done with Don Ross, who just retired, and this is at a field not too far away from the field I just showed, and I show this to highlight the point of when these phosphorus exports occur through the year, but more of the base flow versus event flow export. So from this particular field, for almost an entire year, we had 1.3 pounds per acre, and that's just the subsurface. So no surface runoff is measured at this field. So again, we're over that 1 pound per acre kind of rule of thumb that I mentioned earlier. And then the big takeaway from this study was that we had 8 storms, which composed 85% of the total P export. So you can see the hydrographs there, those spikes in the blue, those gallons per day, and then the pounds of P, not pounds per acre, but just pure pounds of P that were exported during that event. And so just 8 events were well over the majority of P export from that field. And so that several takeaways come from that, right? For one, subsurface P losses can be substantial, really kind of sets the stage for us. And says a lot more work needs to be done here in the area of conservation practices and how to avoid this. And then the fact that storm events and preferential flow are really dominating the loading in subsurface flow. And when I say preferential flow, I'm showing an image of a soil crack in a clay soil there on the right. And these develop in our clay soils when they dry, and those clays crack, they're shrink swell clays. And these cracks can lead directly down to a pipe that's 3.5 to 4 feet underground, essentially short-circuiting the soil matrix and transporting phosphorus directly down into a tile line. And unfortunately, these appear to be more common. Our work has also shown in hay and no-till fields. So soils that are not tilled, that develop a strong soil structure, are those which have these macropores, and more of the preferential flow is occurring. And some really important work from the Lake Erie Basin has also shown that as well, that these no-till practices are also leading to increased dissolved P transport from tile lines and from watersheds. And so lots of work yet to do on management practices. I'll kind of try to tie up here quickly. Our work is now set to evaluate different soil health BMPs on these fields, things like cover crops and no-tills, manure injection, potential usage of manure that has gone through a P removal process. Working with Eric Roy and have worked with Eric in the past on evaluating one system, and we'll be evaluating another manure P removal system coming up here in the next year. So I think it's going to be a multi-pronged approach with both some source modifications, some soil health in-field management practices, and then where our work is starting over the next 4 years, just received funding to look at some end of tile treatment solutions as well. So filter type practices that are attached to the end of the tile lines that can be used to filter out the phosphorus before it's discharged. And then the last point I'll make is kind of how we try to connect these monitoring data to those all important policy and tools, those practice, things that are being used by practitioners out in the state. And the first example of that is the Vermont Phosphorus Index, which is, if you're not familiar with it, it's a tool that's used on every large farm that uses manure in the state of Vermont, and it predicts a risk of phosphorus loss from individual fields based upon the practices and the management of that field. And so we've used our data to update that tool that is used by nutrient management planners and farmers to consider climate change, and also to include this subsurface P-loss routine. We're one of the few states in the country, to my knowledge, that has actually put a tile subsurface P-loss risk routine in their phosphorus index. And then we also have, which I won't talk about today, we've done some SWOT modeling and evaluating increased levels of conservation practices, and we'll be doing in the future evaluation of increased adoption of manure pea removal technologies. If the adoption of those types of systems were to flourish within Vermont, what would the outcome in water quality be? And so I'm gonna stop there. I'll just leave you with a picture of a beautiful, beautiful Covington clay soil in South Hero, which rotationally grazed farm. Farmer took this degraded soil and just did a fantastic job of making it beautiful and building strong aggregates. And so this is kind of at the foundation of where a lot of my work happens here, of course, is how water moves through this, what you're looking at here on the screen, and what it takes with it.
Great. Joshua, that was wonderful. Thank you. On behalf of the Gund Institute, I want to thank Joshua and everyone who joined us online here. And I just want to remind everyone, if you have questions, please enter them in the Q&A. That's the best place for them, not the chat. And I think to start, maybe I'll ask this question that was posed by Stephen Posner, which is, great talk. Thank you, Joshua. Can you say more about the role of farmers in your research? How do they help inform your research questions? And what have you found to be helpful in developing trust with farmers? And I might add also, maybe you could talk about what are the benefits and drawbacks of working directly with farmers in your research approach?
Yeah, I'll start with that. Benefits and it's extremely, I think, gratifying to work with private farmers. And that's one of the great things about it. The other great thing about it is that we're doing research on active working farms that are not an incredibly controlled environment. It's not a plot scale research farm, which are important, but there's been work that has shown that work that occurs on controlled plots, at least in the water quality field, often overestimate the effect of conservation practices. So I think it's really important that we do this work with farmers on their lands and being managed the way that they manage their other lands, not the way we think it should be done as a research farm. And then to Stephen's question about kind of the farmer perspective on this, I think one of the key ways that we involve farmers in this work is for a number of projects, we establish stakeholder advisory committees, and we have those farmers provide input on the BMPs that we will be evaluating as part of our edge of field practice, that we don't come in and bring a practice that is necessarily that unfamiliar or may be a bad fit for a Vermont farming system. We converse with farmers, we see what is actually doable on their farm, and then use that to kind of shape our research. And there's quite a bit of back and forth. And then there's also in the course of research, showing farmers data, showing them updated information on what we're collecting and from their fields is really, I think, enlightening to them and enlightening to us, and to see that, you know, they are concerned and they want to, in some cases, you know, shocked at sometimes what is coming from their fields, and sometimes very happy that nothing is coming from their field. So it's just a really nice interaction to be able to provide that feedback to farmers. I may have missed one sub question in there, Liz.
I think you did a pretty good job.
Okay.
So it was, how do they help inform your research questions? How do you help develop trust with farmers? I think you did that.
Okay.
There is another question, unless you have more to say. There was a question that I think is related, which somebody's wondering about what conservation practices in particular would be used in the experimental watershed, and how widespread among the farmers there.
Yeah, so in the experiment, in the watershed scale experiment, we'll be doing a variety of conservation practices, and we work with NRCS and the state agencies are the ones who help put those practices on the ground, provide financial and technical assistance to do that, working with the farmers. And we'll be promoting a lot of soil health management practices, things like cover crops, no-till, and then where I am particularly interested in focusing a lot of our energies is on manure injection. I think that, you know, the challenges with Vermont in a cold climate agroecosystem where we have frozen soils, that regardless of soil health in these systems, they still become very impermeable in the wintertime when they're frozen solid. And so we just have to keep manure off the surface of these soils, and manure injection, I think, holds some promise for us, and it helps with disrupting some of those macro pores that I discussed in the last few slides as well. So those will be some of the top 3 practices, as well as riparian buffers, and then potentially some new practices like the phosphorus removal structures, the filters that get placed at the end of the tile lines.
Mm-hmm. There are a few questions here in the Q&A box about kind of specific strategies and practices, and I wonder if you can talk about your understanding of whether they would be effective. So here's one from Leslie Parisi, and she says, great talk. If farmland had more trees interspersed, would it help with soil health, runoff, and water quality? So what do you think about the potential for agroforestry?
Yeah, I mean, that's an interesting question. I don't know the answer. I haven't, I think to intersperse trees, I've seen some work where agroforestry is a very promising activity. I don't know of trees interspersed with, in row crop, corn systems like a lot of our work is occurring and a lot of the water quality concerns exist. So I don't really know that the answer to that. I think that there could potentially be some benefits, but then it's a matter of, again, trying to make sure that a farm can farm around those trees if they are in place, and making sure that they fit into the existing management system.
Great. And then there's 2 questions here from Dustin Kincaid. And he's wondering if you've looked at nitrogen to phosphorus ratios of exports. And then also if Vermont has considered 2-stage ditches with man-made floodplain benches to promote phosphorus removal.
Yeah, so good news on one of those. So we often pair our phosphorus data with nitrogen. I do not have the nitrogen to phosphorus ratio data off, at the top of my head. I could certainly, provide that, because we are measuring nitrogen as well. That, and we do see nitrogen losses, and it's just not something that is receiving a lot of attention because of the concern with phosphorus in the freshwater environment in Lake Champlain. But yet we see the pressures on nitrogen management growing in eastern Vermont with the Long Island Sound, and nitrogen being concerned in that marine water receiving environment. So we are measuring nitrogen, but I'm not doing any of the nitrogen to phosphorus ratio calculations, or don't have those offhand. And then in terms of the 2-stage ditches, yes, NRCS is actually adding that as an official conservation practice that can receive financial assistance within the state. I believe it's this coming year. So we have not done any research on those 2-stage ditches. But the state now, apparently that will be an option for farmers that they can select to receive cost share assistance for that.
Great, thanks. This next question is from Ara. Have there been studies that analyze how aquatic macroinvertebrate communities are responding to the increase or pulses of phosphorus in these watersheds? So that might be some of your colleagues.
Yeah, no, I don't know. So, I think that would be for, a stream ecologist or someone. My work, unfortunately, my work does tend to end at the edge of the field. And it's a really exciting place to work because it's the intersection of the managed and unmanaged landscape. But, I tend to stay in the field and right there at the edge of the field with my work.
Okay. I have a couple other questions here. And I would say this might be interesting to other folks in the audience. What do you think are the most important opportunities and needs for research from other disciplines or potential future collaborators that would complement or enhance your research, especially as you're heading into this long-term watershed scale study?
Yeah, great question. I mean, I find that working with social scientists always enriches my work. And in terms of the specific research questions, I don't know that I could, kind of spout those off right now, but in collaboration with social scientists, I think there are so many interesting things to ask about, what are the leverage points for adoption of these various conservation practices? How do feedback loops, like when we talk to farmers and we show them data, what is the right way to present that data to influence change with that farmer? How do we leverage farmer to farmer conversation about these when we have research data in hand? I think there's a tremendous amount of, and Alyssa knows this too. She works with me on some of these things, but I think there's the social aspects of this are large, and then the economics of it too. Of course, it's something that I can't really do myself, but I think that bringing those two disciplines into play could lead to some very, very rich research.
Nice. Just as a follow-up about talking about research, I wonder if you could tell us a little bit more about what it's like to interface with policy. And it seems like you're often the person delivering potentially bad news or saying, hey, this is much more complex and challenging than we want it to be to fix both natural resource problems and support farmers. What's it like to be in that position?
I mean, it's I don't necessarily feel like we're always delivering bad news. We're just delivering what we found. We're just stating the science. And I think there's a lot of gravity to that situation, I think, because policy, my experience is that policy kind of is fairly nimble in Vermont and moves pretty quick. So I think that you feel like there's a great responsibility when you bring this type of information to a policy circle with the knowledge that there may be something that comes from this conversation or somewhere down the line fairly soon. And so I think that I'd say it feels like there's a lot of gravity, but it doesn't necessarily feel like it's bad news. It's just, we're just reporting results.
Great. Let's see, I think we'll move to a question from Caitlin Crossett. In addition to increases in heavy precipitation in the Northeast, that the Northeast has also seen recently a number of significant drought years like 2016 and 2020. How do drought years impact phosphorus export in following growing seasons?
Phosphorus export in following growing seasons. I don't know the answer to that. I think that it's a really interesting question. And I think it's also a very interesting question how phosphorus exports change in years following really wet years as well. Not to kind of twist your question, but in really wet years where there's not much growth, or in drought years. So this is probably goes both ways, where there's not a lot of crop yield. So there wasn't a lot of uptake of those nutrients that were applied. And of course farmers apply nutrients based upon what the expected yield would be in a perfect weather year. So they're applying the, all the nitrogen, phosphorus that would be necessary. And then if there's some sort of impact on that crop, then there is potential for those nutrients to be lost in the coming months to the next year. So, and that is one, I think it's very complicated with tile drainage. I mean, I don't think it's good or bad, necessarily all good or all bad. And that's one argument, I think, where tile drainage allows the crops to reach a fuller yield potential so that they're taking up more of the phosphorus that was applied. And then less of that phosphorus is available for loss.
Okay, the next question is from Bailey Kretzler. How do you see this work interfacing with other statewide large-scale soil health improvement initiatives, for example, enhancing carbon sequestration in agricultural fields?
Yeah, great question. I mean, the carbon as I mentioned, we're going to be doing some soil health monitoring at the watershed scale as part of the SEEP study. In terms of carbon sequestration, I'm not exactly sure how we're going to, interface with other efforts. We do have a pending proposal to do some in-depth carbon sequestration work on a couple fields within the Dead Creek watershed. That would be looking at shallow and deep carbon, working with some others at UVM on that. We should have a decision on funding within a few days here. Supposed to be September 30th, but haven't heard yet. Anyway, so yeah, I mean, we're very interested in that question. I think there's a lot of uncertainty still in the related to the permanence of some of these carbon sequestration claims, and so we're very curious, and farmers are very curious. They're excited about a potential opportunity for payment for ecosystem services for carbon sequestration. And so we'd love to help, determine, what is happening on these soils when we are implementing these soil health best management practices.
It's exciting. I think we're at a time where maybe we'll just do one last question, and any other kind of wrap-up thoughts that you want to share with the group. So this last question is from Steve Bartlett, and they say, thank you, Joshua. I found it interesting that the dry, cracked soils on hay and no-till fields contribute to adding more phosphorus directly to tiles. Are tiles absolutely needed on no-till and hay fields? Is there research to learn if these no-till and hay fields can naturally absorb more water and phosphorus? And maybe a good opportunity to add any other thoughts you wanted to about preferential flow path and that new research that you're doing on tile drainage.
Yeah, so I think the way I would answer this is Heather Darby did some survey work with farmers about a year and a half ago, asking about tile drainage and conservation practices. And I think what is maybe unexpected is that having a well-drained soil enables the implementation of many of these conservation practices, because we are able to dry out that soil quicker. We're able to get onto the fields in the fall and plant the cover crops, or we're able to use no-till practices, which have a tremendous benefits for reducing particulate phosphorus losses and erosion losses. That's why we do no-till in the first place, is to reduce those erosion losses and particulate P losses. But then, so if we have a well-drained soil, we can do those practices and not worry about compaction, which is especially concerning in the Champlain Valley with the clay fractions we have and how tightly those soils can compact if we're on them when they're moist. So I think there's this really interesting relationship between conservation practices and tile drainage. And I don't know that we necessarily have all the answers. I think that the work is very clear from Ohio that shows that we're seeing more dissolved P loss in these soils with macropores that are well structured, and even particulate P loss for that matter. So I would stay tuned. This is a very current and pretty hot conversation in the ag conservation circles right now of how these feedback loops on soil health practices. And so I have no additional thoughts to share. I appreciate the questions, and I'm here at UVM, of course, and can be reached via email if there's any follow-up questions or something I wasn't able to cover. We have tremendous amount of research going on, so I was only able to touch on a little bit of it today.
Great. It was a great talk, Joshua. Thank you so much for joining us. And so on behalf of the Gunn Institute, thank you, Joshua, and to everyone who participated and joined us online. We'll have a video and podcast of the talk today available next week. You can look for it in an email from Nora and on the website eventually. Please join us again next Friday for our next Gund Exchange with Karen Cito from Yale University, whose talk titled Urbanization, Solution or Crisis for Climate Change will be on October 9th. Thanks everyone. See you then. Thanks, Joshua.
Thank you.